So the equation of the tangent to the circle given the external point 5, 0, and the equation of the circle is x squared plus y squared is equal to 5. So the equation of the circle is always in the form of x minus a into bracket squared plus y minus b to bracket squared. This one is equal to r squared, where a comma b, this one is the center of circle, and r is the radius of the circle. So this equation of the circle, this one can be rewritten as in this form. We can rewrite it as x minus 0 squared plus y minus 0 squared is equivalent to r squared, that is 5. So in this case, the center of this given circle is OO. Center O, which is 0, 0. Because in this case, A corresponds 0 and B also corresponds 0. And r squared is equal to 5. So mean that the radius r is equal to the root of 5. So the radius of this circle is root 5. So in this case, given that this one is the center of the circle, the coordinate of the center of the circle is 0, 0, 0. And now we want to find the equation of the tangent from the external point, that is 5, 0. So in this case, if this one is the external point of the circle, we connect the external point to the part of the circle, the circumference. That one is the tangent. So this one is the external point to the point of the circumference now. So this is the external tangent from a point. Now, given this one is the center of the circle, so a center from the center of the circle, we can draw a radius to cut to meet the tangent. So we draw the radius to meet the tangent. So radius to meet the tangent. When the radius is meeting the tangent, this angle here is 90 degrees, and this angle here is 90 degrees. And the radius of this circle is root of 5. So this length from the center to the circumference, this one is square root of 5, and from here to here is also the square root of 5. So you got the root 5, and we need to draw another line, another point coming from this external point to the center of the circle. So in this case, we got the. So in this case, now we are going to use the radius of the circle. We use the radius of the circle. Let us use the radius of the circle and the coordinates to obtain the x, y. The coordinate at this particular point where the radius meets the tangent. Now in this case, we are going to use the magnitudes root of x minus 0 squared plus y minus 0 squared. This one should be able to give us square root of 5. So square root and square root cancel. Now the equation becomes x squared plus y squared is equal to 5. So this was the equation of the circle, which is equation 1. Now to obtain equation 2, first of all, we are going to get the hypotenuse of this given triangle. So using this coordinate and this coordinate, the external coordinate at the center of the circle, we can get the magnitude of this line. So we got square root of 5 minus 0 squared plus 0 minus 0 squared. This one is the same as square root of 25, which is equal to 5 units. So the hypotenuse of this triangle is 5 units. This one is 5 units. Now we got the base and the hypotenuse. We can easily get the height of this triangle. Now, when you open this one, you got x squared minus 10x plus 25 plus y squared square root of it is equal to root 20. So root sign and root sign, they cancel one another. So collect the x squared plus y squared minus 10x plus 25 is equal to 20. But from the equation 1, x squared plus y squared is equal to 5. So this one is equal to 5. 5 minus 10x plus 25 is equal to 20. The value of x is equal to 1. That is the value of x. You see the value of x, you can easily get the value of y. We substitute the value of x in the first equation to obtain the value of y. So the x squared plus y squared is equal to 5. So that is 1 plus y squared is equal to 5. So the value of y is equal to plus or minus 2. Because we are going to get square root of 4. That is plus or minus 2. So the coordinates to the tangent, the coordinates of the tangent at that particular point is x comma y, can be 1 comma 2 or 1 comma negative 2. Where the tangent, now again using the 2 points on the tangent that lies on the tangent, the external point, and where the tangent meet the circle, that is where the tangent and the radius meet. So you can get the gradient. The gradient of the line is equal to using 0.5, 0 and 1, 2 is negative a half. That is the gradient. Using the coordinate 1, 2, we obtain the gradient to be negative a half. Now, using the gradient, which is equal to negative a half, and one of the coordinates, 5, 0. So the gradient and one of the coordinates is going to give us the equation of that given tangent. So 2y is equal to minus x plus 5. So this is the first equation of the tangent. Again, these 2 points, 5, 0 and 1, negative 2, can also give us the equation of the tangent. So the tangent, there are 2 tangents that come from the external points. So we're going to get the gradient is equal to the change in y. So negative 2 minus 0 over the change in x, that is 1 minus 5. This one gives you a half. So we have obtained the tangent, the gradient of that given tangent to be a half. Using one of the coordinates, that is 5, 0, we can get the equation of this tangent.